Okay, let's look at the next exercise, which is at page 11. You see, page 11 takes off with the power supply that we said we wanted to build. So let me share some things with you. Let me try and send you online, but then let me share my screen. Uh, Share my screen. So let's see. If I talk of power supply, let's see. Power supply adapter or power supply units. So let's see, these are what we are talking about. So we all know that if you want to connect a laptop to a what? A power, you see that what we have on the wall is always an AC socket outlet. So that is on the wall. So always you have these kind of things on the wall. So this is where I'm going to plug my what? My input. But then you have these three lines or these three pins. The top one here is what we call the X. Then one is live and one is what? Neutral. So I'm not supposed to take you deep, but I just want to show you. This is what you always do. But this actually is not the power from this wall. It's not actually what is entering your laptop. Something is always done to it. So what is being done to it is in series. The day I told you that first of all, when the power is taken, it passes through a transformer. So let's see an electronic transformer. So an electronic transformer looks like this. These are what you see always in that power supply unit that I just showed you, the adapter. But there's another version of transformer which you see in town. That one is common. So let's see. That one is called a power transformer. Power transformer, pole mounted or whatever. So these are the power transformers I'm talking about. That is when you come to what? Our main power grid. That is not what we are talking about now. We are talking of the electronic one. Then after the transformer, I told you that from there we go to diode. So this is how a diode look like. The symbol is there. Then the diode picture is also there. This is it. This is it, this is it, this is it. But then you always see a shiny part of it. Always remember that the shiny portion is what you call the negative terminal. But the other side is the positive terminal. So every diode that you see, these are different types of diodes. We are not going to talk about that. That's what these are Zener diodes. But this is the normal diode I'm teaching you. That's the rectifying diodes. Fine. Then from there, I told you that you should be connecting what is called a capacitor. So after you are done with the what, when the diode comes in, the next thing is a capacitor. So this is a capacitor. So we have power types. That's the high voltage capacitors. They have low voltage. We are talking of these small ones. We are not talking of power capacitors or super capacitors. Those ones, we use them in big industries. So let's see if we view a super capacitor. Yes, this is how they are. The way the length is, don't see it to be something small. The length can be from the ground to where your knee is. Yeah, it's long. It's a bit long. Mhm. So let me add in an industry in our. So let's see. Yes. So you see the man is leaning on those capacitors, and you see the size, the relative size. So they are always big, as I told you. Fine. Then from there, we say that after the capacitor, we now use a voltage regulator, which is LM7805. I told you something like that. So if you want 5 volts at the output, you plug 78, LM7805. That's an IC. It's an IC. It's an integrated circuit. It's a lot of things put together to get this small thing. So if I show you the circuit diagram, you see. So let's just add the circuit or internal, right? Yes, after for the internals. So this is the internal circuit diagram. It's very big, very big. That comes together to make that small thing that you are seeing. All right. So let me stop sharing this screen. Then I share my simulation side so that we see what goes on over there. I want to just check whether my microphone is working. Okay. So our first thing to do is to choose a transformer, or we should choose the source. Now we are talking of AC source because we are going to convert this AC to DC. So that is it over there. The value is 120 volts RMS. The frequency is 60 hertz. Now the next thing that we choose is a transformer. As I told you, transformer is also under basics. So as I told you, you have to use a transformer to step it down, the voltage, which is what? 120, because what your laptop need is 5, it's not 120. So let's test this input here, the output of the transformer, to see how many volts we are now having. So let me first of all ground the circuit, line the ground. Then I bring a multimeter which can measure both voltage, current, and resistance. So let's try and simulate this. I want to see the voltage coming. I think there's something I'm not doing well, or I'm trying to measure AC, DC. So the AC is still giving us 120. This is because this is not a transformer that can do that. I have to use a step down transformer. So when I step this transformer down to 0.05, let's do that and see. When I step it down, it is now coming to 6 volts. So I'm okay for now because still I'm going to be doing some things to it. So I'll not trim it to just 5 volts. I'll just leave it with 6 volts like this. Now, let's continue by adding more components. So the first component that we have to add is a what? When you check through the book, we have half wave, then full wave. Anytime we are doing half wave rectification, I think I have to stop sharing this. Then I try to show you something about the half wave and the full wave. If I'm talking of half wave rectification, it means I'm using one diode. So the diode that we talked about, if I'm using just one diode like this to build it, I'm talking of half wave rectification. Don't forget, these things will come in the exam. Then when I'm using four diodes, that one we call it bridge rectifier or full wave rectification. So you see we are having four of them. Let me use a practical aspect. Practical, so that you see the picture very well. Yes, so that is it that they are connecting there. We have four of them. We have four of them. Some people also use two. You all achieve the same aim. But in the waveform, you all did integrated science normal, so you know what a wave is. So when we talk of the half wave rectifier and full wave rectifier signal or signal differences. If you look at their output signals, this is how it looks like. Uh, yes, what we are having over here is a full wave because let me show you the half wave first. Let me show you the half wave signal because we've done that in class. And let's see. So this is a half wave. So you see that there are spaces left. You see, there are spaces left there. After you have harvested the signal like this, there's a space. After harvesting, there's a space. After harvesting, there's a space. But then when we talk of full wave, let's try and check full wave. For full wave, it's a different thing altogether. You see, there is no spaces between the what? The signals. So you have this, and that. So that is the difference between the half wave and the full wave. So I'll stop sharing this and quickly let you see the other one too. Now, our input is always a sinusoidal, and that's not what we are looking for. We are just looking for something that is a straight line because DC is straight. DC is straight. So let me think I didn't share the screen. So let me try sharing that. Sorry. Okay, now I've shared this. So what we want to do is that we want to see how the waveform look like. So what component do we use to check the waveform of an electrical signal? That one we use what is called oscilloscope. That one you have to keep it. Oscilloscope. That's the writing there. So I connect this to the input, connect this to the negative side. Now let's simulate and see. When I simulate and double click on the signal, I'm going to see a sinusoid or a sinusoidal wave. But what we want to use to power our laptop shouldn't be like this. It should be straight. So we are going to look at how we can work on it to let it become what? Straight. Now, so we are moving forward. Let's take off this oscilloscope. Then we move ahead. The next thing for us to connect is a diode, as we all know. So I go in there, look for my diode. Let me use one diode for now because we are dealing with half wave first. So when I connect my diode like this, let me bring a high value resistor to keep the voltage constant for me. So we put a resistor over there. Then I bring my scope again to measure how the output of this rectifier has become. We know how the input look like. Now, when we bring in a diode, how does it change the output for us? Let's try and bring some ground over there. Let's bring some ground and see. So when I simulate, you see the way the waveform has become. I told you that with half wave, you'll be able to harvest only one portion of it, but the other side will be chopped off. So in technicality, there's a reason to that, but you are not doing up to that portion. You just have to know that for half wave, this is the way the waveform will look like. So let's see if I use a full wave, how will the waveform look like before I now go to the next video. So let's change this and now bring in a bridge rectifier or the one with 4 diodes. So let's go and look for our bridge rectifier. Then I come and connect that one to and see. So we have this. This is actually the way we connect it. Then this one go top there. So note the way I'm doing the connections. Now let's simulate and see. When we simulate this, you see that the graph has changed. It tells you that this one is a what? Is a full wave rectifier. That is what I want you to know for now. Okay. Okay, so that is it. Let me stop this video here, then we do another one later. So we now know how the diode has changed the, what do you call it? The signal to, but we want it to be straight, just like this white line. We don't want it to be like, but you see that it is doing something to it. So small, we will see how the components are coming in and how each of them is changing the waveform or the signal for us to have the what, the main aim that we have what we have splitted. Okay, so that is it for now. Let me stop it. Then we come another time.